All right, so we're going to finish up section 3.6 rational functions by looking at examples that have a common factor in the numerator and denominator, and also an example that has a slant asymptote. All right, so let's first look at A. Okay, this function, x minus 3 over x squared minus 3x. So first we want to start by factoring. The top does not factor, so x minus 3 stays the same. I am going to put in parentheses though, okay, so I make sure to cancel it together. Now in the bottom, this is just a two-term polynomial, so I'm going to factor it by just grouping them together and factoring out the greatest common factor. So the common factor here is x, and what's left is x minus 3, right? So as you notice that the x minus 3's are the same, so we're going to cancel these out. And we get a function 1 over x. This is the equation we're going to use to calculate vertical asymptotes. All right? And we can use it to calculate everything else as well. Now what happens when this factor cancels? Because normally you would have thought that there was going to be a vertical asymptote at 3. Instead, what's going to happen at 3 is there's going to be a hole. All right? So vertical asymptotes here, we're going to set the denominator equal to 0. So x equals 0, so I have a vertical asymptote at x equals 0. Now what's going to happen is that if the factor cancels, there's a hole. So if the factor cancels, there is a hole. Right, so I'm just going to put it on here. I don't think they're going to ask you for the value of this hole, but since the factor is x minus 3, okay, we're going to set x minus 3 equal to 0 and get a hole at 3, at x equals 3. Okay. Now I could find the y value of that hole, because if x equals 3, I don't want to plug it in here because I'd get 0 over 0. I don't want to plug it in here, 0 over 0. But if I plug 3 in here, I'm going to get 1/3. So the y value is 1/3. And I'm going to show you how that happens. Okay, I'm going to show it on the graph when we finally get to the graph. All right, so only one vertical asymptote, because after it's reduced, there's only one factor in the denominator. All right. What about horizontal asymptotes? Let's compare the degrees. The degree of the top is 1, and the degree of the bottom is 2. So the top is less than the bottom. So this is a case 1. And all case 1s have an asymptote at 0. Okay, this is my favorite case because it's easy. All right, x-intercepts. We're going to set the fraction equal to 0. Now, you can set either fraction you want to equal to 0, but I'm going to choose my, my factored one. So here what I'm going to do is I'm going to multiply both sides by x, and I'm going to get the x's cancel on the left and gets 0 on the right. So there actually is no x-intercept, right? So you better not set the original function equal to 0. Set the reduced one, okay? On the y-intercept, this is the one that it doesn't really matter. You're going to get the same answer, right? But on the y-intercept, if we let x equal 0, I'm going to get 1 over 0. Which is does not exist because we can't divide by 0. So we have no x-intercepts. We have no y-intercepts. All right. So let's go ahead and graph that. We have a vertical asymptote at 0 and a horizontal asymptote at 0, which is why we must not be crossing our horizontal asymptote at all. And then we have this hole at 3, 1/3. So I'm going to draw an open circle there. Okay. But let's go ahead and graph this and get an idea of what this function looks like. So I'm going to graph the original function first. All right, so if I graph this one, I should see the asymptotes at 0, and then I should see it kind of going here. All right, so graph. So it's coming from negative infinity, approaching the asymptote from the bottom, and then on the left, and then on the right, it's coming from positive infinity, approaching the asymptote from the top. Now, if I were to find the value at 3, okay, so I can calculate, which is trace, okay, second trace, I can calculate the value, number 1 here, and I could put 3 in there. Now, when I put 3 in there, it's not going to give me a y value. Okay, it's kind of blank. It doesn't put a y value there because 3 is a whole. Now, if I were to graph the other function, okay, 1 over x, because after we simplified it, that's what we got, correct? All right. So when I hit graph here, you should see that the red graph is going to overtake the blue graph absolutely everywhere. All right. So here the red graph comes, here it's coming, right? 1 over x is exactly the same as our original, but if I were to calculate the value at 3, okay, I'm still on the blue graph here, so the blue graph is not giving me a y value. If I scroll down to the red graph, 3 comma 0.33333, which is 1/3, and it puts a point there, okay? So it's the second function that kind of tells us where that point is, which is why we are going to plug 3 into the reduced fraction, all right? So a whole in the original, in the blue graph, and then the red graph tells us where that hole is, all right? Oh, let me graph this. Let's draw it. So it's coming from negative infinity, approaching the asymptote from the bottom, and then it's coming from positive infinity, approaching the asymptote. Now I'm going to reach that hole, kind of skip over it there. Okay. All right, so let's go ahead and do B. All right, moving on here. Let's look at what this equation is going to do. All right, so I want to factor this. Right, the top only 2 terms. So I'm going to group it. I can take out an x squared, and I'm left with x minus 2. On the bottom is x minus 2. Right, so we have a common factor again. So I'm going to cancel this out, and I'm just going to get x squared. Okay, this function simplifies to x squared. So if I graph this, it's probably just going to be a parabola. Okay, but let's go ahead and go through the motions here. What's the vertical asymptote? Right? What happens if we set the denominator equal to 0? There is no denominator. Right? So I'm just going to write none. Okay, no denominator. Horizontal asymptote. Let's look. Let's compare the degrees. Okay, what's the degree of the top? 3. What's the degree of the bottom? 1. Right? So the degree of the top is bigger than the degree of the bottom. So this is n is greater than m. This is a case 3. And so on a case 3, we need to find that asymptote by doing the division. Right? We need to find the slant asymptote. So in case 3, we're going to say no horizontal asymptote. That's the technical answer. But, okay, there is an oblique asymptote, and I need to do the division. Okay, we need to divide x cubed minus 2x squared by x minus 2. Now, because this divisor is just linear, I'm going to go ahead and use synthetic. Okay, so all of this work is for the slant asymptote. So I'm going to use synthetic division here. X cubed, x squared, x constant. So I'm looking at a 1, negative 2, 0, and 0. Right? So bring the 1 down, 2 times 1 in the next spot, 2 times 0, 0, 0, right? So the answer is 1 degree less. So this is x squared, x constant remainder, right? So our slant asymptote is at the quotient only, right? So our slant asymptote is at y equals x squared, which is weird. This one is kind of weird because the graph is x squared, the asymptote is x squared, but sometimes that happens, okay? So let's go ahead and do x-intercepts and y-intercepts. What happens if we set y equal to 0? We'll set the x squared equal to 0, and we'll get 0. So we have an x-intercept at 0. Y-intercept, if I set x equal to 0, I'm going to get 0, right? So we have x-intercepts at 0, 0, and a y-intercept at 0, 0. Okay, so this is kind of all we have to go on here. All right. Now I usually do put the slant asymptote on there, so I am going to put an x squared on here, right, as an asymptote. But if I were to graph the original function, I just want you to see what's going to happen. So let me graph the original. Parentheses, x cubed minus 2x squared divided by x minus 2. Graph. The graph looks like an x squared. Okay, so this graph crosses its slant asymptote absolutely everywhere. It's really strange, right? But this equation here is just equal to x squared, right? That's the takeaway. All right, so I did find one slant asymptote. The next one we're going to find another. Okay, but the main takeaway, guys, is that if the hole, gosh darn it, where is the hole at? Okay, if something cancels, a hole exists, right? So there should be a hole in this graph at 2, at x equals 2. So what's the y-coordinate? Well, if I plug 2 in here, the y-coordinate's going to be 4. All right, let's check that out. So if I calculate the value at 2, it should be blank. Okay, it is. It doesn't put a cursor on there, all right? But if I go ahead and graph x squared, right, remember the red graph should overtake the blue graph, and it does, right? The red graph is not going to have a hole in it. So calc value at 2, all right, I'm still on the blue graph here because my type is blue. So if I'm going to scroll down, now I'm on the red graph, and it puts that hole right there at 2. So let me fix my graph here, 2, 4. And put a big old hole there, okay? Because that's what happens if you have a factor that cancels. You don't have an asymptote there, you have a hole there instead. All right, so moving on, last one. Okay, a rational function with a slant asymptote. This one's not going to be as weird as b on the other side. Okay, let's go ahead and factor this. The top factors multiplies to -5, adds to -4. So x minus 5, x plus 1. The bottom is already, can't be simplified any further, right? It's its own factor. Nothing cancels, right? So we have no holes. Okay, the denominator is going to be where our asymptotes lie. So vertical asymptote, okay, occurs where the denominator equals 0. So if I set the denominator equal to 0, I get x equals 3. Okay, that's the equation of my vertical asymptote. Horizontal asymptote. We're comparing the degrees. The degree of the top is 2, and the degree of the bottom is 1. So the top is greater than the bottom. So we have n is greater than m. So this is a case 3, right? And in case 3, there is no horizontal asymptote, right? None. But, okay, there is a slant asymptote, right? And we have to find it, okay? So we need to do this division. So again, the denominator is linear. So synthetic division works here. I'm going to go ahead and divide by 3. 1, negative 4, negative 5, right? Because we got x squared, x constant. So if I do the synthetic division here, okay, just chug right along, then this is the x, this is the constant, and this is the remainder, all right? Our slant asymptote is the quotient only. I'm going to ignore the remainder. This right here is where my slant asymptote is. So the slant asymptote is at y equals x minus 1. Okay, 1x minus 1. Just the quotient. Right? So if you have a case 3, there is no horizontal asymptote, but you do have to find the slant asymptote. Alright? Alright, x-intercepts. Set your fraction equal to 0. Get rid of your fractions. You're going to multiply both sides by x minus 3. And so it's going to cancel on the left and become 0 on the right. Set each factor equal to 0. So I get x equals 5 and x equals negative 1. So my intercepts are 5, 0, and negative 1, 0. Right? Y-intercepts. Set x equal to 0. So 0 squared minus 4 times 0 minus 5 over 0 minus 3. The only thing left here is negative 5 over negative 3, which is 5/3. So to help, I'm just going to write that as a mixed number. Okay, 3 goes into 5 once with a remainder of 2, right? So this is 1 2/3, just to help me graph this. Okay, so I am going to graph this, all right? Let's put our asymptotes on there first. All right, the vertical asymptote is at 3. Right. The slant asymptote is at x minus 1. I want to graph x minus 1 on this graph. So x minus 1 has a y-intercept of negative 1 and a slope of 1, right? So it's going to cross here at negative 1, and then it's just going to be up 1 over 1. Okay, so I'm just going to kind of get this going here. Here's my slant asymptote. It's this linear function. Okay. So we kind of have 4 pieces, right? This pie here, okay, this large area here, this little pie here, and then this large area here. We have four regions on this graph. All right, x-intercepts 5 and negative 1. Right? And y-intercepts 1 2/3 here. Okay, so this is what it looks like so far. All right. So let's go ahead and plug this into our calculator to see what the calculator says the graph looks like. All right, here we go. Get the glare off here. All right, so you can kind of see the slant asymptote here. The graph is just following along that asymptote, and then it's going to take off when it hits that vertical asymptote, okay? So it goes straight up. So we really just have 2 sides of that vertical asymptote going. We're not going to get any part of the graph here in this region here, okay, or in this region here. It doesn't look like. So I'm going to start at the asymptote. And then I'm going to cross my x-axis and my y-axis where I need to, and then I'm going to approach the vertical asymptote in the positive infinity direction. There we go. Now on the other side, okay, it's coming from negative infinity, and then it's just going to approach that slant asymptote from the bottom, right? So when I come from negative infinity, I want to make sure I'm crossing the x-axis and then just approaching that asymptote. All right. So this is the only section for this week, guys. It really is pretty redundant, right? We're always just doing the same things. Vertical asymptote, horizontal asymptote, x-intercept, y-intercept. So practice, 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 and make sure you can do that. And as always, if you need extra help, just let me know. I'm only an email away.